Hi, I am Varun Joshi and welcome to day 16 of our Certified Kubernetes Administrator 2025 course. Not all nodes in a Kubernetes cluster are created equal. Some nodes might have special hardware like GPUs, others might be reserved for critical workloads, and some might be undergoing maintenance. So how do we control which pods get scheduled on which nodes? That's where taints and tolerations come in. So I have a diagram here. Before we see what the diagram talks about, let's read the definition. Taints and tolerations help control which pods can be scheduled on which nodes. Taints are applied to nodes, whereas tolerations are applied to pods. In this diagram, I have three nodes: a green node, a blue node, and a purple node. The green node has a taint, color is equal to green. Blue node has a taint, color is equal to blue. And the purple node has a taint, color is equal to purple. If you see this diagram, green node has green pods, blue node has a blue pod, purple node has purple pods. These pods are placed on this node because in the pod configuration, we have said that these pods have the matching toleration to be placed onto the green node. Here we are saying key is color and the value for that color is green, and the green node has a taint that says color is equal to green, which is why these pods are placed onto the green node. Similarly, the blue pod had the configuration color is equal to blue, which is why it was placed on the node that has a taint, color is equal to blue. The purple pods would have had color is equal to purple tolerations, which is why this node which has color is equal to purple taint could tolerate those pods. If you understood this concept, this is all there is to taints and tolerations. Now let's see what are the use cases in which you would want to use taints and tolerations. First is dedicated nodes. For example, my green node could have GPUs and these nodes didn't have GPUs. In that scenario, I would want my pods which are hosting application that requires GPUs can be placed on the green node. And similarly, there could be a scenario where purple node has high memory and any pods or applications that require high memory can be scheduled onto the purple node. So first purpose is dedicated nodes. Second is isolating critical workloads. Maybe the green and the blue node are used for production, which is why I want my critical workloads to be scheduled on these two nodes only. Third is preventing scheduling on control plane nodes. If you have observed in the entire course, we have been spinning pods left, right, and center, and we have seen that the control plane node didn't host any pods. There is an exception where we did see a pod host on the control plane node when we were discussing manual scheduling, but we'll discuss that use case later. Fourth is maintenance mode. For example, I see that the purple node, I want to upgrade the firmware for this node. In that scenario, I can apply a taint which says maintenance is equal to true so that no pods are scheduled onto the purple node. That's one case. Another is node resource constraints. Maybe the blue node has less memory and I do not want to schedule memory intensive workloads in the blue node. So I can use taints and tolerations for that. I have discussed a handful of use cases. If you broaden your imagination, you can think of many use cases where taints and tolerations could be used. Let's go to the CLI and apply taints to our nodes. I will run kubectl get nodes and I see there are three nodes in my cluster. There is a control plane node and I have two worker nodes, and my Kubernetes cluster is running version 1.31.4 of Kubernetes. Then I will run kubectl taint node. I will name my node, my second cluster, worker. We'll be applying taints to these two nodes currently. And then I will write storage is equal to SSD, so that any workloads that require SSD can run on this worker node. Then I will write NoSchedule. NoSchedule is the effect of this taint. It says that any new pods that wants to run on this worker node should have the required toleration. So they should have a toleration that says storage is equal to SSD. Then I will press enter and it says my second cluster worker is tainted. Before I describe this node to you, let's apply a taint in the second worker as well. I'll name this worker 2 and instead of SSD, I will write HDD here for normal hard disk. I'll press enter now and it says that worker 2 is also tainted. To see whether the taint is applied successfully or not, I can always run kubectl describe node my second cluster worker. I'll press enter. If I scroll up, I'll see there is indeed a taint applied, and that taint is storage is equal to SSD NoSchedule. Similarly, we can check this for worker 2, and if I scroll up, you will see that worker 2 has a taint that says storage is equal to HDD NoSchedule. I'll clear my screen. Now I will run a pod. kubectl run my pod 1. I'll say this pod will use image is equal to nginx and I'll press enter. We have created a pod. We have 3 worker nodes. 2 nodes we have applied taints, so we know that this pod does not have a toleration, so it won't run on those 2 nodes. But we still have a control plane node, and we'll see whether this pod is scheduled onto that control plane node or not. I'll run kubectl get pods -o wide so that I know on which node this pod is scheduled. I'll hit enter and you see the pod is still in pending state, and if I run kubectl get nodes, I see that these 2 nodes, we know that it won't be scheduled. But why didn't this pod get scheduled in control plane node? The reason for that is the control plane node already has a taint pre-applied, and that taint prohibits any workload to run in the control plane. So if I run a kubectl describe on the control plane node, I will see that if I scroll up, I will see that there is a taint node role.kubernetes.io control plane NoSchedule. But Varun, in the last lecture when we were discussing manual scheduling, we were able to run a pod on the control plane node. How was that possible? Remember one thing. In the last lecture, we said that scheduler makes certain considerations before placing a pod onto a node. And these are those considerations. It checks for resource availability, taints and tolerations, affinity and anti-affinity rules. Hence, applying or running the pod that has toleration onto a tainted node or anywhere else is the function of scheduler. In manual scheduling, we were bypassing the scheduler, which is why we could run the pod onto the control plane node. Now what I'll do is I'll go back to my terminal again and I'll see whether my pod is scheduled or not. I'll run kubectl get pods -o wide and I see my pod is still in pending state. Now let's create a deployment manifest, and in that manifest we'll add the appropriate tolerations. I'll write new file. I'll call this deploy.yaml. I'll press enter, and since we already know how to write deployment manifests, I'll use the extension that I have installed to automatically generate a deployment YAML for me. And you can also install this Kubernetes extension if you are using Visual Studio Code. Then I'll go here, I'll go to my deploy.yaml, I'll write kind deployment so that it autofills. It has autofilled. I'll name this, let's say app1 deploy. Okay, and the container name would be Nginx. The image that I want to use will also be Nginx. I want this deployment manifest to be minimal, so I'll also remove this optional section which you should be using in production for documentation purposes, and then I'll also remove this section which you should also be using in production scenarios. Once we discuss limits and requests, we'll add this section. I'll remove this too. Then metadata is app1 deploy. Selector is I want this to be app1, and the label that the pods will have will also be app1, so that all the pods that are created by this deployment are managed by this deployment. I'll also remove this. This looks good. Now I want to add tolerations. So where do we add tolerations? We add tolerations under the spec section, and we know that this spec section defines the properties of the pod that we are creating, which is why we are defining the containers under it, and similarly we'll also define tolerations. I'll appropriately indent and then I'll write tolerations here. Tolerations is a plural, which implies a pod can have multiple tolerations. Similarly, you can have multiple taints onto your nodes. We'll see this later in this lecture. I'll hit enter. I'll again indent it, and then you see that I'm starting this with a hyphen. Hence, tolerations is a list, which is why you can have multiple tolerations in a pod. So let's discuss the fields that will be inside toleration. So we'll have a key first, and then we'll have an operator. After that we'll have value, and then we'll have effect. There was a recent construction work at my place, and we installed something called Covelites, and in here I'm using an acronym to remember what all things are inside tolerations, and you will see that these fields are used in other manifests as well, so it is better if you remember these things. So I'm spelling cove with a K, so K as in key, O as in operator, V as in value, E as in effect. If you want to use this acronym to remember this, be my guest. If you feel this is not the way you remember things, then it's all right. In the key section, I have added, let me do one thing. I'll run history, and I'll quickly just copy this command. I'll go here. I will just paste this here so that you have a reference point. So the taint that we applied, it says storage is equal to SSD. If I want the pods that are part of this deployment to run in this node which has a taint, then I will have key is equal to storage here, and I like to keep these things in double quotes, so I'll write storage here. Why double quotes? Because you will also at times you will have boolean values in here like true, false. In that scenario you want to put that in double quotes. Then operator would be equal. We are saying that storage equals to value for that will be SSD, and then effect will be NoSchedule. We are saying that any new pods that wants to be placed in this node will only be placed once you have the appropriate toleration. Another thing that I want you to remember is the effect that the taint has, the toleration should match that effect, and the operator is equal. There is another operator known as exists. We'll see that in a little while. Now if I run this deployment should have the pods run in this worker node. So let's go to the command line. I'll run kubectl apply-f, and then I'll run deploy was the name of that YAML. I'll press enter. Okay, it says deployment created. Then it has an error here. This error is because we have this line pasted, so you can ignore that error for now. I'll run kubectl get pods -o wide, and I see that there is only one replica created, and that replica is running in my second cluster worker, which is expected. Now why did it create one replica? You see that the replica section is not there, so let's add replica, because by default it created one replica. So I'll add a replica section, and I'll mention 3 replicas. This file is getting auto saved, so I'll go here. I'll again apply that manifest so that my deployment is updated. Should it be replicas? Should be replicas. Okay, it's configured. So if I run kubectl get pods -o wide, I will see that now 3 pods are created, and all those 3 pods are running in this worker node only, because control plane has a taint and the second worker node also has a taint, which only allows pods that have a toleration, and the value for that toleration is HTD and the key is storage. We know that. And now let's increase the number of replicas to 5, and I'll again apply that, and you see that still my pods are created in this worker node. So we understand this. Now let's do another thing. Let's create a pod manifest now. I'll keep this as is so that we can always refer this for reference. I'll go here, I'll write kind is pod, and this will create a pod for me. I will name this pod my pod 2. I'll go here, I will remove the label. I don't want a label. Again, name will be Nginx and the image name will also be Nginx. We'll remove this section. Now let's add tolerations here. I'm using directly a pod, but as you know, in production you would always be using deployments, and inside deployments you will configure tolerations under the spec section of the pod. This is the spec section for the deployment itself, and under the template you are filling things about the pod, and here under spec section you have tolerations. Similarly, if I go here, this is directly the pod's spec section, and inside the spec section I'm creating tolerations, and here I'll indent it. I'll write key operator value, and then I'll have vect. The key here I want is same storage. The operator I want here is exists. Okay, we'll see this in a while what we are doing. The value, we'll fill this in a while, or maybe not fill it at all. The effect will be NoSchedule, and as I mentioned, this effect should match the effect that is on the taint. So the nodes that we have tainted have NoSchedule effect. We are saying that key storage, the operator must exists. We don't care what the value for that is. As long as the key storage exists, place this pod onto a node that has a key storage. And we know that both our nodes, if I talk about our node 2 that had a taint which says worker node 2 here, and instead of SSD we had HDD. We are saying that place this pod onto either of these 2 nodes. I'll remove the value field from here because value is not needed, because we are only concentrating on the key and this key must exist. So we'll go in the CLI, I'll run kubectl apply -f, and in the deploy.yaml we also have this pods manifest, and I should name this my pod 2. I'll go back here, I'll press enter, and it says this is unchanged, and I should remove these from here now because it is not going to the third YAML. I'll go back, I'll apply this file, and it says that this deployment is unchanged and my pod 2 is now created. I will hit kubectl get pods -o wide, and what I see is my pod 2 is now running, and it is running on worker 2. I want you to understand that the scheduler could have chosen either worker or worker 2. It chose worker 2 based on its algorithm. It would have seen that these 2 nodes are of equal configuration and this node is already running these many pods. So let me run this onto worker 2. I hope you now understand the exists operator in the tolerations part of the manifest. Now let's do one more thing. Now let's apply multiple taints to our nodes. What I'll do is I'll run kubectl taint node. I'll use worker 1 first, and in worker 1 I will add a taint that says environment is equal to, let's say, production, and same the effect will be NoSchedule. I'll press enter. It says the node is tainted, and in the node that has HDD I'll add environment is equal to dev, and here I will write worker 2. I'll press enter and it says nodes are tainted. Now let's do one thing. I'll kubectl delete -f. I'll delete everything that we have created thus far, and I'll run kubectl get pods. I'll see see that only my pod 1 is running, which we created imperatively. Rest, everything is deleted. Let's go back to our Visual Studio Code. Now, what I will do is I will just copy this manifest. I'll create a new file. I'll call this deploy2.yaml. I'll paste this manifest here. Now let's add one more toleration here. What we will first do is we'll change this to exists. The value will not be there because we are using the exists operator like we saw earlier, and the effect will be same, will be NoSchedule, because the taints that we added also had NoSchedule. Both the taints that we added in both the nodes had the effect NoSchedule. I'll then go here. I'll again add those 4 sections. So let me just use the magic of copy paste. I'll rather copy it from this deployment because this has all the fields. I'll copy this. I'll go to deployment 2. I'll paste this here. I'll remove tolerations altogether, and then this looks good to me. And then the second toleration that I want to add here is for env, and I will say environment equal to prod. So what we are now saying is, first you check that the taint with storage key must exist, and we know that both of those nodes have this. Second, we are saying that ensure that environment is equal to production. Environment is equal to production is in worker node 1. Hence, all these 5 replicas will be placed in worker node 1. Let's go to the CLI and see this in action. I'll run kubectl deploy -f. Oh, I'm sorry, kubectl apply -f, and now we are dealing with deploy2.yaml. I'll hit enter and it says the deployment is created. If I run kubectl get pods -o wide, I will see that all these pods are placed in worker node 1. If I run kubectl get nodes, you see that this worker node, all these pods are running in this worker node. If I run a kubectl describe node on this node, then you would see that these are running here because this node has 2 taints. Environment is equal to prod and storage is equal to SST, and the effect for both these taints is NoSchedule. Now let's do one thing. Let's now delete everything we created and also remove the taints. This will also teach us how do we remove a taint. kubectl get pods get all. Let's say I will write kubectl. I could directly delete the deployment kubectl delete deployment like this, or I could also run kubectl delete -f. Whatever is in this file deploy2.yaml, just delete that, and then I will also delete our standalone pod. I'll write kubectl delete pods, and I want to delete my pod 1. It is also deleted. If I run kubectl get all now, I should only see the default Kubernetes service. What I'll now do is I'll remove the taint. So how did we apply the taint? We wrote kubectl taint node my second cluster worker, and then we wrote env is equal to prod, and then we wrote NoSchedule. To remove a taint, you just add a hyphen here and it will delete that taint. If I press enter, it says it is untainted. Then I'll do the same for the other taint. I'll write storage is equal to SST NoSchedule and a hyphen at the last. This will again remove that taint. And then I'll do something similar for our worker node 2. I'll write 2 here and I'll remove this taint, and similarly I will remove the environment taint as well. All the 4 taints are removed. If I run kubectl describe node, I will see that it says taints are none. Now before I let you go, I want to discuss few advanced use cases with you. I'll go to my diagrams and I'll scroll down. We have a similar diagram like we used before. We have a green, blue and purple nodes. We have applied relevant taints to these nodes. For example, the green node has color is equal to green, blue node has color is equal to blue, purple node has color is equal to purple. Then there are various effects for these taints. The first node has the NoSchedule effect, the blue node has PreferNoSchedule, and the purple node has NoExecute effect. The NoSchedule effect says new pods will not be scheduled unless they have a matching tolerations. The keyword is new pods. Let's assume that when we applied color is equal to green taint to this node, there were few pods which were already running. If I apply this taint, those pods will continue to run on this green node and will not be evicted. In case any of those pods failed, they won't be recreated onto this node, but if they continue to run, they will keep on running till their lifetime on this node itself. Any new pods that will be scheduled, new pods will only be scheduled if they have a matching toleration. Second is PreferNoSchedule. Kubernetes try to avoid scheduling pods but doesn't enforce it strictly. For example, if I have a new pod that is about to enter into my cluster, then it will prefer the untainted node first. For example, if I want to schedule this pod, a normal pod which does not have any tolerations, it will be scheduled on untainted node. In case untainted node is occupied and cannot withstand any workloads, then scheduler will schedule onto the blue node because it says PreferNoSchedule, and this is what the definition says. Kubernetes tries to avoid scheduling pods but doesn't enforce it strictly. The last one is NoExecute, which says existing pods without a matching toleration will be evicted from the node. Let's say when I applied this NoExecute to this purple node, there were 3 pods already running. As soon as I apply this taint, all those 3 pods will be evicted because my effect is NoExecute. This is the difference between NoExecute and NoSchedule. NoSchedule will continue to run the pods that were running before the taint was applied. However, NoExecute will delete any of the existing pods which were running before the taint was applied if those pods do not have the matching tolerations. I hope this is clear. Now we have green pods here running on the green node, and green pods, the tolerations that I have applied, clearly effect is NoSchedule. This effect that you supply at the pod level must match the effect that is supplied at the node level. Here as well, the blue pod has this matching effect. The purple pod also has the matching effect, NoExecute. Now let's understand what will happen if I have these many workloads to be scheduled. Now, before we discuss the scheduling for these pods, let's first understand one thing. We had 3 nodes before, and these 3 nodes were running these many pods. Then I added one more node to this cluster. I didn't apply any taint to this node, and then now my cluster has 4 worker nodes. Let's now discuss the pod placement. Let's talk about the yellow pod first. This has a toleration color is equal to yellow. We know that this pod cannot be placed onto the purple node or onto the green node because they have strict taint effect, NoSchedule and NoExecute. So we are left with 2 options, untainted node or the blue node. Why the blue node? Because the taint that is applied onto this node is liberal in nature, which is PreferNoSchedule. But what will be the first preference of the scheduler to place this pod? The first preference would be the untainted node, and in case the untainted node is occupied and for some reason it cannot place that pod onto the untainted node, then the scheduler will schedule this pod onto the blue node as second preference. But for this discussion, let's say this was placed onto the untainted node. Then there is a normal pod. For normal pod as well, these 2 are out of the question because they have strict taints, NoSchedule and NoExecute. Blue node is in contention and untainted node is also in contention. This pod will be placed onto the untainted node as first preference. If untainted node is occupied, then blue node will be assigned to this pod because the taint applied to the blue node is liberal. What will happen to the green pod? Before we discuss this, let's say there are two green pods that have to be scheduled. They cannot be placed onto this or onto this because of strict taint effect. These two can be placed on untainted node or they can be placed onto the green node. But Varun, what will be the preference? And these can also be scheduled onto the blue node. Mind you, in case untainted node is fully occupied and the green node is fully occupied, then these two pods will be scheduled onto the blue node as third preference. But let's discuss on the first two preferences if there are two pods where these pods will be scheduled. In my lab, I created 12 pods, 6 were created on untainted and 6 were created on the green node. Then I created 20 pods. Then also the distribution was 50-50. If I only spun one pod, then this pod was placed onto the green node. For this discussion, let's say one pod was placed onto the untainted node and another pod was placed onto the green node. And let's say there is a blue pod. Blue pod, we have options of the blue node and of the untainted node. Now, what will happen to the blue pod? In the blue pod as well, I saw something similar like we saw for the green pods. The blue pods were also equally distributed between the blue node and the untainted node. These two nodes were not applicable. But there is one important distinction. When it comes to blue pod, when I spun a single pod, the preference was given to the untainted node. But with the green pod, when I spun a single pod, the preference was given to the green node. So in essence, PreferNoSchedule is lenient in nature. As we saw, Kubernetes tries to avoid scheduling pod but doesn't enforce it strictly. Hence, the first priority was given to the untainted node and then the blue node. In case you had a deployment that had, let's say, 6 replicas, then you would have seen sort of 50-50 distribution between the untainted node and the blue node. And for this discussion, let's say this pod was placed onto the untainted node. I want you to imagine a scenario. Is this fair that green pod, blue pod, these pods are placed onto the untainted node when they have their own designated nodes? Shouldn't they be placed onto their own nodes? Any pods that have tolerations should ideally be placed onto the nodes that have the respective taints. How do I achieve something like that? To achieve something like that, you use a combination of taints and tolerations along with node affinity. In this example, we are using color coding, but imagine if green node belonged to project A and untainted node belonged to project B, then is it fair for project B to run workloads of project A? Not fair, right? And I'm saying project, but this segregation could be based on department, environment, or even high configuration nodes. Maybe green node had GPU, and I do not want the pod that should be running on the high GPU node be running on an untainted node, on a node which does not have GPU. Hence, it is imperative that in production environments, you use a combination of taints and tolerations and node affinity to achieve the desired pod placement. That wraps up our deep dive into taints and tolerations. We learned how taints restrict pod scheduling, how tolerations let specific pods override these restrictions, and how we can apply them in real-world scenarios to better control our workloads. In the next lecture, we'll explore node selectors, node affinity, and anti-affinity. If you have any questions, feel free to ask them in the comments section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much.